Hi everyone, I'm Wu, and I'm gonna record a video for question 2 in homework 3 for the course probability and stochastic processes. So in this question, it said x is uniform in range from A to B and y equals to x2. And in the first part A, it asks us to find and draw the dance function of x and the function of x. So here, since my camera focus on the paper. So since x is uniform, in range A to B. So we can write the dance function as following. It starts from A to B and is 0 out of this range. And then the function of x, it starts from 0 in the beginning when x is less than a, not equal to a, and it keep increasing in a range from A to B, and finally it reach 1 since it's uniform in AB. So yeah, it can be write as larger than or equal to or larger than. It's fine. So to draw this function will look like this. This is x. This is the dance function of x. So suppose A is right here, B is right here. So it will look like this. Since it's uniform, so all the value in this range is equals to 1 divided by b minus a, and all of this range is all 0. So for this function, how to draw it? I'm gonna draw it right here. Vertical at horizontal axis is x, and the vertical is function f(x)(x). So A is right here, B is right here. So in the beginning, it starts from 0. So it will like horizontal line is all 0. Its value is all 0. And when it reaches A, it keeps increasing. And it keeps increasing. It's a straight line right here. It's a straight line. So it increases up to the value 1, and it stays at 1. So that's the graph for this function. So for question B, the question said the A is -1 and B is 3, and it requires us to find and draw the dance function for y and the function for y, and find the expected value for y. So to solve this, since the y equals to x2 is given by the question right here, so we can and also it defines a equals to -1 and b equals to 3. So this function will look like this. The density function for fx will look like this. A is -1, b is 3, and the value 1 divided by b minus a is 1 divided by 4, equals to 1 divided by 4. Okay, I gotta make sure my camera focuses on the paper. So for this, the function for fx, sorry, the function for y, it will look like this. Since it's x squared, so it will look like this. Yeah. And since we need to find the range from -1 to 3, so it's so at the point -1, it equals to 1, and it also equals to 1 when the value is 1. I'm sorry, the graph looks so unreal. I'm sorry about that. So y will equals to y equals to 9 when x is equals to 3. So so from this graph we can observe that the density function for y equals to 0 for the range y less than 0 or y larger than 9. And for the range 0 less than or equal to y less than 1, it will have two roots. One root right here, one root right here. So y equals to gx equals to x squared, and from this equation given by the question, we can get the x equals to positive or negative 2 times square root of y. So we can actually calculate the value for fy y in this range, since there are two roots. So it's x1 is root 1, and it's x1, and x2 divided by g x2, derivative of x2. So and this is equal to 1 divided by 4, and this right here is just the derivative of this for x1 is -1. So for the left root, for the first root is negative second square times square root of y. So take derivative of this, we can get the negative 2 times, I'm sorry, take the absolute value, and plus this is the same, but this is right here. The right root value is right here. So calculate this, we can get the result of 1 divided by 4 times the square root of y. And for the range 1 less than or equal to y less than 9, from observing this graph, we can see there are only one root. Since this root is out of range, so we only got one root. So we can write it down right here. Y y equals to fx, since there are only one root, just there's only one term of this equation, so it's also 1 divided by 4 divided by 2 times, and its value is this. So combine all the results we get from above, we can write the density function of y in this form. And we can also calculate the function for yx. So in the beginning it's 0, and then it becomes to this value, and then it becomes to this value. And after that it becomes to 1, since it's a uniform function. So we can also write all this information into just one equation. So it's another form. So this value right here starts from 0 to 1. So it starts from uniform y minus 1. This represents the position of y equals to 1. Plus 1 divided by this one. And it starts from uniform y minus 1 to 9. So it's y minus 9 right here. So also we can write this into this equation, just the one equation. So it is it starts from 0 to 1 and plus 4 times 1 divided by 4 times 1, and it starts from 1 to 9. So this part is basically the same. So, and we can draw the graph based on these two equations. So first I'm going to draw the density function for Fy. So at the range starts from 0 to 1, it will look like this. So it will look like this, and its value right here intersect when y equals to 1 is 1 divided by 4, and then from the range 1 to 9, it will look like this function, 1 divided by 8 times the 2 times root of y, 2 times square root of y. So it will look like this. And intersect here, value is 1 divided by 8, and the intersect value right here is 1 divided by 72. So I just connected these two lines, and it's all 0 otherwise. So this part and this part is all 0. So The density function is basically look like this. So for the function, fy in this range, from range 0 to 1, it will look like this function. So this function look like this. This here. So the intersection right here is 1 divided by 2. And since it's a uniform function, its final value will reach. So its final value will be 1. So in this range 1 to 9, and we can already connect this. And we already know that after this part, it will stays at the value 1. And in this part, it will look like this, since we calculate this function from using the value right here. So this all this function is already connected. We do not to draw the vertical line to connect them. So it will look like this. And the final question asks us to find the value of expected value for y. So we can use this this equation right here. Take derivative, the differentiation of y plus from 9 to 1, from 1 to 9 times dy. Then this part is equals to 2 times square root of y plus from 1 to 9. I'm sorry, missed the dy right here. So by solving these two functions, I'm gonna solve it right here. Plus 8 2 divided by 3 goes from 1 to 9, and for when y equals to 1, it will equals to 1 out of 6, and when y equals to 0, this all goes 0. So the left part is 1 divided by 6, and the right part, this part is equals to 1 by 12, and when y equals to 9, this part is equals to 27. When y equals to 1, this part is 1. So the final value is 7 divided by 3. So that's the answer for this question. Thank you for watching.